Hey everyone, in this video we're going to go over volumes for Octane in Houdini. Now on one side, if you've been using Octane in Houdini for a while, we've made quite a few improvements under the hood and in the UI department. But also if you're new to working with volumes in Octane Houdini, then we will be going over all the basics, even some of the more advanced setups that are possible. So let's get started. Let's quickly talk over the improvements we've made. So for one, we've changed the UI. It used to be that this kind of grid mapping area was the main place where you selected or set volumes. However, in more recent releases of Octane, we have the universal volume, which can basically accept any kind of grid, and you can set the grids you want to use for shading in the material. And so the general volume grid area becomes more important, where the plugin automatically detects any volumes inside, and we can enable or disable them and then use them in the shader. Just note that if you make significant changes to the grids inside of the object node, you might have to refresh the grids parameter list using this detect available grids button. This grid mapping really only applies if you use the medium volume, which is like the legacy Octane volume shader, which has some cool applications still, but is also more limited in some ways. In the past, when you're loading volumes in the SOP context, they were much slower when you had a VDB versus a Houdini volume. That is fixed. There was also some transform issues. So if you had your volume transformed in the SOP context using like a transform node, for example, what you saw on the viewport did not match what you saw in the IPR. We fixed that. We also added a new node we'll go over later. It's called the volume detection node, which has some pretty cool use cases that we'll also go over later. So let's set up a basic volume. So let's drop down a geonode, call this smoke, and then we're going to dive inside and we're going to drop down a Pyro configure billowy smoke node. It's going to run for a moment and then we'll see this smoke here. Let's drop down the transform to make this a little bit smaller so we can fit that into our viewport. But we see that right now nothing is displaying here in the scene. And for one, that's because here under the Octane params, currently our Octane object type is set to geometry. We will want to set this to volume. And when we set this to volume, we get an error pop up here that says inconsistent VDB/volume grid size detected. This is currently not supported. Please ensure all grids have the same voxel size, and then it goes into how to fix that. So if we dive here into our object and we middle click on this node and we look at our voxel size, we can see that density, temperature, and flame have a voxel size, in this case of 0.016, or before the transform it was 0.1. But then the velocity has a voxel size of 0.2. Twice the size. And that's because here in the output settings of the Pyro solver, we have this resample volumes thing enabled and the voxel size scale set to 2. And this is because in many cases, you don't really need to have a super high resolution velocity grid. For most cases, that's unnecessary. However, that's a limitation of the current Octane Houdini implementation that's not supported. And so to fix that, for one, we could just uncheck this resample volumes box and we can see that we now have a volume here. The other option is to use a VDB resample node and plug this here in the middle of it. Now let's turn this back on. Yep. And we're going to plug in this node on both sides, and we're going to, under group, we're going to select velocity, and under the reference, we're going to select density. And now we can see that it's also working, and it also fixed this voxel size. So we can see before it's 0.2, and then after the VDB resample, it's 0.1. And it's also quite fast, it seems, so it shouldn't really be much of an issue in terms of performance. So if you still have access to your Pyro solver, then it's easier to just uncheck this, and that way you don't have to use the resample. But in case you maybe already cached out your simulation, or maybe you're importing a simulation from something like Embergen, or the VDB file already has this kind of like baked in, well, you can use the VDB resample to resolve this issue. Let's quickly talk about a few other limitations that Octane currently has. One is that if you use like a copy and transform, for example, to like duplicate your volume around the scene, this is currently not working. And that's because if you can see here, it kind of like duplicates those volumes, but Octane only can read one of them. So right now this breaks the viewport. We're planning to hopefully support this in the future, but right now it is not. And so the way you work around this, and the same if you were using like pack and instance, for example, or like a copy to points type thing, is instead of using kind of like the SOP level duplication, we can drop down an instance node on the object level. We can call this like smoke instance, for example, and then we can pick the smoke as our instance object, turn on fast point instancing, and now we can move this around. And the benefit of this is it doesn't duplicate the data, so we're not using more RAM or anything like that, but it's actually creating a fast instance of the object. And so we could even, drop down a grid in here, for example, and get like a bunch of copies for basically free. And we can kind of hide the original here. So that's, if you were doing like a cloudscape or something, you could do that. You could even use like an attribute just float and kind of like do your typical instance thing and like do like a random size to kind of like get different sizes, that sort of thing. So you need the volume to be like duplicated around the scene. That's the way that it currently works. Alternatively, if you're like, doing some kind of advanced smoke sim where there are different layers, so you might have like a main explosion and then you have like smoke trails or like a shockwave, and they're separate volumes that are all within the same object. The way you can do that is just by splitting them out. So you can create like an out shockwave, for example, and then create a new geometry object, and inside here use an object merge and merge in your shockwave. Make sure to have this set into this object in case you have some like transforms or something. And that way you could split out like your different volumes as well. Of course, you need to make sure that if you create a new object to also, set up the volume and add anything here if you like needed some kind of grid mapping or something to make sure that those settings are set up there as well. However, this is not needed for the instances, of course. Now, one other option you have when it comes to loading volumes or VDBs into Octane is to, instead of loading it directly from SOPs, loading it directly from a VDB file. So we're going to select VDB file under our Octane object type. And then in this new Open VDB tab, we can now select a VDB file. So in this case, I actually have this simulation that I created in Embergen, and I'm going to load this here. I enable show sequences one entry. I can see the whole animation. I'll load this. And I'm going to ignore this for a second because I think it's having trouble loading it because this only goes up to 63 frames and I was past that. So I'm going to go back to 44 frames and press detect available grids. And I'm also going to load this here in the file inside. This actually won't be loaded in Octane. Like anything that's inside here will be ignored. I just want this in here just so I have a viewport reference. Otherwise the viewport would just be empty. And we can see it's this kind of like shockwave type spirally animation. If I hit open IPR here, we should see this volume here in our viewport. And it's very light, so we need to apply a shader here again. Okay, here with a little bit of tweaking, we got something pretty cool, and we can even play it forward, and we can see the animation here in the viewport. If you want the most efficiency out of like especially playback performance and just loading times, this is actually faster than loading it directly from SOPs, at least for the meantime. If you have a simulation where we had in our earlier example, you can just use a file cache node and make sure to set this to VDB and have this time dependent turned on, and then you can just save this out, and then instead of loading it from directly within Houdini, loading VDB files through here. As you're playing within SOPs and kind of modifying your volume, it makes sense to have it there. But I think when your asset's done or you're importing it, I think this is actually a better option in many ways. And what you can do is, completely disable this, or just have like, I don't know, a bounding box in here or something, or some kind of like low resolution preview. And since the contents of this node are ignored, you're not wasting compute on the viewport display if you don't want it. One of the cool thing is that this VDB file method does not have the limitation of not working with different voxel sizes, so you won't have to worry about that with this option either. If you want your volume to have motion blur in the normal SOP volume method, you really just have to make sure this velocity grid is loaded. And by default, that is the grid that's going to be loaded here. We've had a bug recently, and I think it's still in this build too. If you load it via SOPs, you have to kind of like increase the velocity scale higher to like 10, while if you load the VDB file, the default velocity scale should be accurate. Hopefully it's going to be resolved soon, but in the meantime, just be aware of that. And then on the VDB file, to enable velocity blur, you have to hit this checkbox. While on the volume, if a velocity grid is found and it matches this name, it'll automatically be there. If you don't want motion blur, you can just disable this velocity grid and it will hide it and it won't load it at all. Going back to the simulation from earlier, I tweaked the volume a little bit. Just in the Pyro solver, I modified a few things like the disturbance and the turbulence. And I'm kind of happy with how that's looking. And so let's jump into the material editor and add some shaders. So right now we just have kind of like the default volume look going on. So let's go ahead and add some materials. One option, if you just have a quick and dirty kind of volume you want to create, is to just drop down Octane Quick Material, set this to medium, and just drag and drop this onto the volume. And this basically gives you all like the basic controls you can use to kind of shade this volume. However, if you have plans to do something a little bit more complex, or just in general want more flexibility, you can drop down Octane Material Builder, dive inside, delete this material standard surface, and let's drop down standard volume, and plug this into the medium tab, not the material tab. And we basically get the same thing that we just had before. However, we can plug in textures and stuff into a lot of these inputs, which makes that more flexible. I won't go into depth into all the parameters here. Just briefly glance over a few of them. So density is just generally like your thickness. You have your volume step percentage, which basically defines in how much detail the render engine steps through the volume. So if you increase this to like 2, for example, which is like 200% of the voxel size, you're going to get much faster render times, but also going to lose detail. So you kind of want to find a trade-off there between detail and render times. Raise step increase factor is similar, but it actually starts increasing the step range, which is a kind of good option, I think, because you still get to have some of that detail, but also get some performance improvements. Scattering is basically the light, like, scattering around inside of the volume. So if we just completely disable this, we see we just have like this black cloud basically. And if we make this brighter, we can see that it really isn't like redirecting any of the light rays. It's just like absorbing some of the light, where scattering actually bounces around light within here. And so of course we can set a color for the scatter. We can also change the anisotropy. I don't know exactly how to pronounce it, but that basically defines when the light bounces, does it bounce, like if you set this to 1, it basically just bounces just right ahead, which is kind of the same as almost as the scattering being disabled. -1 means that the light primarily like bounces the opposite direction that it was coming from, so kind of going back towards the light source. And then 0 is kind of a more balanced, like the light bounces everywhere type thing, which is in most cases what you would want. Transparency kind of acts like absorption and under other render engines. In many cases, I think if you want to add color, scatter is probably the right place to do that, but you can also do that in the transparency channel. Kind of almost does something similar to density, I think, where you can kind of make the smoke more opaque or more transparent. But I think it's also a good way to just kind of like, get your smoke to be darker to some degree, especially once the scatter is like turned down a little bit. You can kind of modify things here too. So kind of a balance. A lot of these things kind of tend to affect the density of the volume. And then we have our emission, and by default this is set to black body. And black body means that it uses this temperature channel to create emission according to that temperature. So it doesn't just affect the brightness of the emission, but also the color, right? Let's turn this black body intensity up a lot so we can see it. If we up this Kelvin, not only does the light get brighter, it also gets more blue. Right, so if we turn the intensity back down to kind of compensate for that, we can see that it's like a more cool light, versus if we turn this black body Kelvin down a lot and then kind of compensate for it in the intensity, we can see like maybe 300 is too low. We can see like a very red warm light. And this is kind of the same with like, if you have a hot blue flame or like a less hot like campfire, you're gonna get different colors. You can also set this to density, and this kind of ignores all these settings down here and basically just does emission based on density. But you also have this emission channel, which you can use to color your emission. And if you set this to channel, you will see that everything is lit up. And I found that you can use this as you have like specifically an emission channel, like a color that's also multiplied like by your density or something like that. But like if you have a color that doesn't also have some kind of like alpha value baked in, everything is going to be lit up in this way. So in most cases, you can actually use density here and still use an emission channel here. And we're going to do that here in just a second. So let's say you have a smoke like this, but you want to introduce color into the smoke. How do we do that? Okay, so let's set up the volume to actually have color here in the smoke. So first thing, under Pyro source, we want to click up here where it says initialize and add source color. And you will see that this will add a color with a default value and an alpha, which we actually also need. I initially, when I played with this, I missed the whole alpha attribute, and I had some issues with the color kind of having these black edges. That was kind of the missing piece. So make sure to add the alpha attribute as well, which happens if you initialize the color. Then we actually need to, write our color in here. So let's use a attribute adjust color. Drop this here after the velocity node, and let's set this to noise. And let's increase the element size here, something that's interesting. This looks pretty cool. And then we also have to make sure that both the alpha and the color attribute are actually going to be rasterized. And finally, in our Pyro solver, here under the sourcing tab, we need to add one more source, and this will be our color. We want to set this to blend and make sure this is set to vector, since our color is a vector volume. And let's set this to source volume will be color or CD, target volume will be CD, source weight will be alpha, and then target weight will be alpha as well. And now if we reset our volume, we still don't see any color because currently the viewport actually doesn't know what to do with this color field. And so the node we want to use is called volume visualization, and that lets us preview this in the viewport. And then here under diffuse field, under smoke, we want to set this to color. If you were doing emission, you could also set that here under emission color field, but in this case, we're just going to do basically a scatter color. And now if we run the simulation, we can see that our color is being injected into the simulation, which is pretty cool. Since it's smoke, the colors do kind of mix and stuff, which is to be expected. So let's move this up to like 71. We have the color in here in the viewport, but it's not in the actual render yet. So the first thing we have to do is here on our object, since we have a new field that wasn't there when we initially kind of set this volume up, we want to select detect available grids. And now you can see that we also see a color grid here. So that makes sure that's actually going to be loaded. And then in the material, we now need to assign this color in here. And so in this case, we'll want to put this into the scatter color. So we can drop down our CD in here and we can see that we have some color now. Changing our scatter color to white will help give it some brightness, because basically the scatter color channel is multiplied on top of the scatter color. Okay, so let's say instead of having this color affect the scatter, let's say you wanted to do a nebula or a flame or something like that where the color's in the emission. One thing that you might do is, let's remove the scatter color here. You might think to set this to channel and then put the color in here. However, we can see that there's a bunch of emission happening outside of kind of like our actual volume. And that's because our color grid specifically keeps color data outside of just like where you can see it. So what you can actually do instead is set this to density, and this color channel will still work, but it will just multiply it over the density. The same thing I think with black body, you can still use the color here to modify the color, even if you're using, for example, the temperature to drive the emission. So in this case, we still have our scatter going on. But one thing you can actually do is if you turn this transparency up to 1, and then reduce the emission, we can see that we have like a transparent volume basically that's just emissive. So if you think of like a nebula, this is basically what you would have, which is kind of cool. Now, one other option when shading your volume, and this is how Octane used to work until the medium standard volume was introduced, and it's still a valuable solution, is to use the medium volume shader. And if we plug this in instead, we can see that by default everything's black because the scattering is at 0. So if we turn this up, we actually get a pretty similar result here to the medium standard volume. As you can see, there aren't any inputs for defining grids to be used in here. And so that is actually done on the object here under the grid mapping. So density, scattering, and emission grid is what's going to go here to absorption, scattering, and emission. So one thing we can do is if you wanted to do an emission for an explosion or something like that, is you can drop down an emission texture and plug that into the emission side. And then on the emission ramp, you can plug in a volume ramp, and this is the same of course for any of these other ramps. And let's set this to something like magma, and as we change this value, you can see that we're coloring this volume using this ramp. The value that is driving this is whatever value is been put in here into the emission grid. So in this case, this is temperature. So we're basically using this remap to remap the temperature, which is pretty cool, especially for like Pyro or flames and that sort of things. That is a really cool workflow. There's actually also a way to do this with a medium standard volume, but it's a little more complicated. And if that's kind of your goal, this is still a very good solution. And you can do the same for the scattering, for example. So if we plug in the scattering ramp here, just a refresh here real quick for everything to reload, we can see that we're coloring our scattering ramp. And this max value basically changes how everything's remapped. So obviously in this case 0 for density would be somewhere out here, and then as we go through the volume we get denser and denser. So yeah, this is another cool way to kind of like shading your volume. And in a second I'm also going to show how you can actually do something similar here with the medium standard volume as well. Another cool thing that Octane has is displacement. So we can actually use a noise, for example, and plug this into the displacement here. And then let's drop in a transform 3D to be able to change the size, and let's change this power to something higher so we can really see what's going on. Maybe not that high, let's do like 5. And maybe let's remove the scattering, and let's just make this like a really dense, maybe dark volume, so that maybe it's a little bit more obvious. And as we change the power, you can see that this volume in this case is actually being pushed in one direction. But you can use this to give more detail to your volume. So maybe let's change the scale here a little bit. And maybe also what you might want to do is use a tool range node, So I think by default this is from 0 to 1, so I might want this to go from 0 to -1. Maybe let's keep this at 1 and then set this to do this copy and paste and basically make this like a zero-centered value, so we can see like we're getting all this extra detail in our volume, and this is obviously pretty exaggerated. Yeah, but we can see that we're getting some free details there that you maybe didn't have in your source volume. And one other cool thing that we added is the ability to use the volume to texture node. And the way this works is that you point this at an object, and then you can select the grid, and then you actually can use this grid to either even color an object, it can even be a surface, and it basically will sample the volume from that position, or you can use that within a volume to kind of like use multiple grids and kind of like combine them or remap them, that sort of stuff. One caveat at the moment though is that you cannot use the same volume that you're shading. So in this case, what we'll actually have to do is do a copy of this, and maybe what you would want to do for efficiency's sake is to write this out to a VDB and use the VDB file method, because this actually doesn't double load the volume, it only loads it one time if it sees that it's the same VDB file. But for this sake, let's just use a null here to create an out node. And then in this other object, we're going to delete all this and going to use an object merge. We're going to select the out and the other object to merge this over. Now, one thing is important here is that we remove the material from the second object, and let's call this smoke sample, because we just want to sample from here. And then also, we don't actually want these both visible because we just want to sample from the second smoke. So we're going to, under properties and visibility, we're going to set this to hide object and render. And what this will do is that the second volume will be loaded but not visible in the render. So you can see if I move this around, we don't see anything happening here. So now in the material, we can point this to our smoke sample, and we can plug this in and, for example, plug this into our scatter color. And let's get a grid name here. Let's get density, for example, and let's use gradient, plug this into the input. And now we can use, for example, infrared. We can also use the range here, tool range, to change the range that we're sampling. So we get a very similar kind of thing as the volume ramp. However, we can do some other cool stuff here too. For example, we can change the projection method. So we could use a distorted UVW projection, plug that in here, and then put a noise in here into, for example, the translation X. And again, we kind of have a similar thing, but instead of distorting the whole volume, we're just distorting this color channel, basically. That's one thing you can do, but you can also, adjust the colors. So use like a tool image adjustment at the end, and, play with brightness adjustments here and change like the gamma, for example. What you can also do is combine two channels. So if we plug this into our emission color and we set the emission color to channel, again, we get all this extra brightness here, but we can now sample the density, and let's say we sample the temperature, or in this case, let's do this, and then do multiply, and multiply by the density in the end again to make sure that we're only really applying the emission there. And then we can also add another multiply to like brighten everything up again. So let's set this to like 20. And so this is another way to work. And this kind of gives you a lot more flexibility. I don't know in terms of efficiency if this is more efficient. It might be a little bit less efficient than this method up here with the volume ramp. However, you also have a lot more options. So really cool, flexible workflow. And we're hoping to eventually remove this limit that you can actually just point this at the same volume. But right now, it's something to just be aware of. All right, finally, there's one more element that we have to talk about while talking about volumes, and that is actually volumes that are not like fog volumes, so your typical smoke or explosion or cloud or anything like that. But we could also create surfaces using volumes, and that's using SDF. So let's create one of those. So let's drop down a geometry node. Let's go inside. Let's create a sphere. Let's up the resolution here a little bit. Let's do like 64, maybe by 64. And inside, let's create a VDB from polygons node. And when we do that, we will see for one it disappears, and we still have our sphere here, but instead of it being like polygons, it's kind of like this pixelated looking thing. And that's because it's still a volume. As you can see, there's still a VDB volume in here, but instead it's defined using an SDF volume. And really what that means is it's kind of like a fog volume, but the difference is that instead of it having like a density value that's between, from starting from 0 being not dense at all up to like, 1 or beyond for like a denser area. It instead describes the distance to a surface. So if you were to sample a voxel right on the surface, it would give you a value around 0. If you were to step out around a distance of 1, you would have a value of 1. If you were to step inside the volume and were to sample a value there, you would probably have a value of -1. But we can actually test this, and if we drop down volume slice node, and let's set this to two-tone from -1, we can see that the blue values on the inside are our negative values, and the warm ones on the outside are our positive values. And maybe let's up the resolution here so we can actually see a little bit better what's going on. Maybe we need up these exterior bands so we can see more. But yeah, so you can see negative values on the inside, positive values on the outside. Now, currently we don't actually see it here in our viewport, and that's because, again, like with volumes, on our object we have to set this to a volume. And then under volume type, we want to set this to SDF. And now that we set it to SDF, we can actually see our object here. Now let's apply a material. Let's go over here, drop down Octane Material Builder, drag this on here, and as opposed to like the fog volume or the smoke, this actually does accept the material because it is a surface. It's just a different kind of surface, an SDF surface. And so what's cool about SDFs is, for one, you can use something like the volume noise SDF, and let's select that, and we can see that as we add this noise to this volume, we can see that we get some deformations here. We're also getting some weird artifacts. One way I found to reduce these is to disable this deactivate button. But the other thing is that when we're pushing out this volume basically to the edges, we're quickly hitting the limits of the volume that's there. We can see this by dropping down a VDB visualize tree node. Here we have our sphere in the middle. You can see that these are basically our active voxels or active areas of the VDB, and as we're kind of hitting those limits, we're getting these kind of ugly errors. And to reduce those, we can just expand these exterior band voxels. Maybe we can fill the interior too. That's probably also not a bad idea in this case. And this much improves things. Some nodes, like the volume noise SDF, also has this setting here to automatic expand the outside. So if I push this further, it will automatically like expand the volume to make sure that we don't clip, which is also a great solution. But I've really found that if you leave this deactivated enabled, that we're getting some weird errors within Octane. So leaving this deactivated is something that you should probably do. But so yes, we kind of getting this cool surface, and we can play with these noises, and there's a lot more you can do there. Like maybe let's select this Manhattan cellular noise, and let's disable the fractal here so we can get a more simple view of what's going on. We can turn this down, and we can see in this case with the Manhattan, we're actually getting more of like a crystally rock type structure. But there's a lot of really cool stuff that you can play with, and that's kind of about the limit that we'll go into here. If you look online on like Houdini SDF modeling or SDF noises, those sort of things, there's a lot of cool stuff that you can do. A lot of people that create like rock models from scratch and things like that use kind of an SDF noise workflow. Can't talk about volumes in Octane without talking about SDF. One other thing I need to mention is that in Houdini, there is 2 volume formats. So the VDB format is kind of a more modern, sparse volume format that's universally used in a lot of different software. However, Houdini also has its internal volume format. And the way you can tell which one is being active currently is, for one, if you middle click on your volume, you will see that it will say VDB volumes, and it'll have this red kind of infinity sign, which is the VDB logo. Now, in this case, if we disable convert to VDB, we can see that now it says grid volume. We can see that it's a cloud instead of this VDB logo. Now, for the most part, Octane can read either one of those. However, there's one thing where it really matters, and that's when it comes to vector fields. So vector fields like velocity or color in this case have 3 components. Velocity has X, Y, and Z, and color has red, green, and blue, which still is called X, Y, and Z. And the Houdini native volumes or legacy volumes or whatever you want to call it, they can't handle vector grids. They split them out into these 3 components. Now, when it comes to the velocity, we can actually load these using the velocity X, Y, and Z. When we detect them, you can see that it loads all those. However, when it comes to shaders, like if you're wanting to use color in the shader, we cannot use these component grids. This is a pretty easy fix. You can use, for one, a convert VDB node and plug your volume into this. Obviously, if you're using the Pyro solver, you can just enable this convert to VDB checkbox. Otherwise, we can use the convert VDB node. We can set this to VDB, and now this converts our volume to VDB. but we still have these components, right? So how do we get them back into like one vector field? And for that, we can use the VDB vector from scalar node. And now if we plug that in after that, we can see that now we get our velocity and color grids back into one vector grid. Obviously, and the Pyro solver makes all this easy by just hitting convert to VDB, and then you don't have to worry about that. But if for some reason that's not an option for you, or you're not using the Pyro solver, this is something that you can do. But if you just have density and temperature and a set of grids that's just a float value anyway, then you don't have to worry about this. And like I said, the velocity is the only one where we are currently supporting these component grids. I wanted to mention a few troubleshooting tools that Houdini has that you can use to kind of figure out what's really going on. Because sometimes it's tricky to know what problems are maybe on the render engine side or your shader setup and what problems are actually within maybe the volume that you're dealing with. So, and especially with volume, sometimes it's hard to know, like not all of them are visible, and sometimes it's hard to know what's really going on. So the first one that we've already used before briefly is called the volume slice node. And when we plug that in here, we can pick a source volume. So let's say, for example, temperature. And if we plug that in here and we can see our offset, we can actually see kind of like the temperature of our volume displayed here as like a grid, and we can kind of like move through the slice. Alternatively, we could do something like look at our color. And as you can see, the color is not actually limited to just the density area, but it goes far beyond that as well. Just kind of like there's a lot of color data that's kept on the outer skirts. So that's a really, really useful thing. The other one that I sometimes like to use is called the VDB visualize tree node. And this one you might want to use in certain cases to kind of know what areas of your VDB, because VDBs are sparse. So instead of filling the whole grid, kind of the whole like bounding grid of the volume, we're actually only like using these kind of, they're called leaf nodes. So it kind of keeps information only in the areas that are actually filled. And so we can visualize those, even visualize volume voxels to points. And we wanted to, we could even bring our attributes onto those points. So for example, if we select color here, and then we select point with values, currently this is just writing it to this VDB vector 3F. So maybe we need to rename this attribute. So let's rename it from VDB3 V3F to color, and it doesn't like that. Already existing attribute. So in this case, we can see actually our color attribute being written 2 points. So I hope this was a good introduction into volumes for Octane for Houdini. I hope you're kind of having enough there to get started. Feel free to reach out on the Discord if you have any questions. Volumes are a really cool thing. I'm hoping that we can maybe improve some of the plugin functionality even more. However, in the meantime, I think there's a lot of possibilities here. Thanks for watching and happy rendering.